Yesterday we mostly finished off chapter 17. Remember chapter 17 is where we introduced benzene and the concept of aromaticity. Right? We talked about some different criteria that molecules needed to satisfy in order to be aromatic. They had to have this continuous pi system, which meant they needed to be cyclic. They needed to have alternating double bonds or p orbitals on every carbon, and they needed to be planar. In addition to that, they needed to satisfy a requirement about numbers of pi electrons in the pi system. Right? So we can either count those for aromatics as either having an odd number of electron pairs, or it has to fit this Huckel's rule, which says that it has to have 4n plus 2 pi electrons. Okay? So we went through some examples of that. We were able to pick out aromatic compounds. We talked a little bit about stability and how aromaticity could affect acidity. And we were deeply involved in learning how to name organic compounds, and we just ran out of time. All right, so I know it's been hard to wait till this morning to do the next level, but we're going to go over a few examples of doing polysubstituted benzenes. And after that, we're going to switch over to chapter 18, where we take what we learned about benzene and we're going to start to look at its chemistry. Okay, so reactions and such. All right, so any questions on all of this? All right, let's do a clicker then. All right, so let's look at just more examples here where we have more than two groups. Of course, because those terms, ortho, para, meta, all were terms that describe the relative position of two groups, we can't use them if we have more than two. All right, because we wouldn't know, we don't list ortho, or, there'd be no way to tell what was what. So at that point, we have to just go to numbering. Okay, so again, just like before though, the first thing we want to do is look for one of those monosubstituted benzenes that has its own special name. If there isn't one of those, then we just number it, name it and number it based upon substituents onto benzene. Okay, and we're going to number the substituents to give the lowest possible numbers. Right? If we have an exact tie, then we break the tie with the alphabet. All right, so if we look at this first one, is there one of those monosubstituted benzenes in that first upper left one? No, not really, right? We had nitrobenzene or bromobenzene. So all of these we have to do on their own. Where should we start numbering this to give the lowest substituent numbers? Right, so we're going to start with number 1 where this nitro group is, because then if we count counterclockwise, we end up with 1, 2, 4, and that's the lowest combination of numbers we could have. 1, 2, 3, 4. We're just going to list the substituents in alphabetical order. We have 2 bromines, so we have a 2, 4 dibromo, 1 nitrobenzene. Okay? I don't know that we got to do all of these. What about the second one? Is there a special molecule hidden in there? No, not really on that one either. So where do we start numbering for this one? On the bromine, right? Because we, no matter where, as long as we start where one of the substituents is, we're always going to have a 1, 3, 5. Right? So we're going to start at the position that gives that has the lowest, comes first in the alphabet. And then we're going to go around the ring, so the second group is first in the alphabet. Okay? So, or is second in the alphabet, I guess. Would it be 3, 4, 5? All right, so this is going to be 1 bromo, 3 chloro, 5 ethyl benzene. Okay? Easy. The next one, the only thing we need to know is, we're just going to start numbering it like this. We could do it either from the top chlorine around this way or the bottom chlorine up around the other way. It wouldn't matter. What about the bottom left? What would be the parent name? Benzene or something else? Toluene, right? So toluene is right here. Okay? So how many of you had ever used, when your kid built those like model cars or model planes or something like that? That glue, has toluene in it. So if you know the smell of airplane glue, then you know the smell of toluene, Not that, I built a few of those, but it's not like I was just constantly smelling the glue or anything. But it does have that smell. Okay, so there's toluene. So when we have toluene or any of these monosubstituted benzenes as a parent, the substituent that goes with that parent will always be number 1. Okay? So then we're going to count this to give the second substituent the lowest number. So we're going to go 1, 2, 3, 4, 5. Okay? And so we're going to list those other groups in alphabetical order. So we have 5 bromo, 2 nitro toluene. Okay? All right, let's just do one of these. Which one should we do, the middle one or the one on the right? On the right? So, well, that's just like what we did today already. So this one has aniline. It's right here. So that's going to be number 1. Symmetrical, it doesn't matter which way we count it. I'm going to count it this way, 2, 3, 4, 5, 6. So we would just have 2,6-dichloroaniline. Okay, what would be the parent for the one in the middle? Right here. It's phenol. Not phenyl, phenol. Which one? Phenol. All right? Okay, so that one would just be what? It would just be 1, 2, 3 bromo, 5 ethyl phenol. Right? All right, so that's all the naming we need to know. So let's just pause this one out. Everybody got that?